Since the dawn of time, humanity has looked up at the night sky and wondered, are we alone? But the question has evolved. Now it's, could we live somewhere else? As Earth faces the strain of overpopulation, climate change, and dwindling resources, scientists turn their eyes outward. Billions of stars, billions of planets. But how many could cradle life? The search for a habitable planet is not just science fiction anymore. It's a desperate quest for survival. Not too hot, not too cold. The Goldilocks Zone is the sweet spot where liquid water can exist. Without water, life as we know it can't thrive. Venus is scorched, Mars is frozen, but somewhere between lies the perfect balance. Astronomers now scan the skies for worlds orbiting at just the right distance from their stars. Every exoplanet discovered is a potential key, but the right temperature alone doesn't guarantee life. It's just the first clue. A habitable planet needs an atmosphere, a shield and a cradle in one. It protects against deadly radiation, regulates temperature, and allows the chemistry of life to unfold. Earth's air is 78% nitrogen, 21% oxygen, and a delicate blend of gases that has evolved with its inhabitants. Too thin, and radiation burns the surface. Too thick, and pressure crushes it. The perfect atmosphere is a cosmic rarity, a fragile balance billions of years in the making. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These six elements compose nearly everything alive. For a planet to host life, it must have these building blocks in abundance. Volcanic activity recycles them, oceans mix them, and sunlight fuels them. Without this elemental symphony, even the most Earth-like planet would be sterile rock. Habitability, it turns out, depends not only on location, but on chemistry. The unseen dance of atoms that creates everything from DNA to oceans. Every planet's fate depends on its star. Too close, and it's scorched. Too far, and it freezes. But there's more. The star's age, size, and temperament decide how long life has to flourish. Red dwarfs live for trillions of years but unleash deadly flares. Blue giants shine bright but die young. Our sun is the rare middle child, stable, generous, and long-lived. It's not just Earth that's special. It's the kind of star we orbit that gives us time to evolve, to grow, to dream. Invisible but vital, Earth's magnetic field deflects solar wind, streams of charged particles that could strip away our atmosphere. Without it, we'd become barren like Mars, whose weak magnetic core allowed its atmosphere to escape. A habitable planet needs a molten heart, churning with metal and motion, to generate this shield. It's a planetary heartbeat, protecting every living thing from the star that gives it life and threatens it at the same time. Water is life's most loyal companion. It dissolves nutrients, regulates temperature, and carries energy through ecosystems. But it's also a storyteller. Frozen ice caps, flowing rivers, or hidden oceans beneath alien crusts. Each tells us about a planet's past and potential. Scientists now look for biosignatures, chemical hints of water's touch. When the James Webb Space Telescope peers at distant worlds, the first question it asks is simple. Is there water here? Even with the perfect temperature, air, and water, a planet isn't habitable unless it sustains balance. Ecosystems are intricate feedback loops. Plants breathe out oxygen, animals breathe it in, bacteria recycle carbon, oceans store it. Life doesn't just exist within the environment, it creates it. That's the paradox of habitability. To be habitable, a planet must already host life that maintains the conditions for life. Earth is not just alive, it's alive because it's alive. With Mars missions and lunar bases on the horizon, colonization is no longer fantasy, it's the next human chapter. Yet every simulation reminds us how hostile other worlds are. Radiation, dust storms, toxic air, and bone-crushing cold await us. To colonize another planet, we must become planetary engineers, recreating Earth's systems from scratch. Domes, biospheres, artificial magnetospheres. Our survival will depend on mastering the science of habitability itself. In the end, the search for a habitable planet mirrors our search for meaning. We scan the stars, but the more we learn, the more we realize how miraculous Earth truly is. Its balance is no accident. It's the result of billions of years of cosmic luck and biological harmony. To find another habitable planet is to find another miracle. And maybe, before we seek to live among the stars, we must first learn how to care for the one home that already sustains us, the pale blue dot that made us who we are.